The world's industries make an almost endless list of products, requiring an almost endless list of equipment, from simple pumps needed to fill beverage bottles to enormous presses that shape steel into car doors. To make sense of it all, we can organize the types of equipment in two ways: by the job it does, the equipment's function, and the industry or customer vertical where it is used. We'll start with the equipment's function. Let's take an example. The equipment needed to produce a seemingly simple product, the humble contact lens. On the factory floor, we find the equipment that actually does the work, making the contact lenses. This is the industrial machinery. The exact machinery will depend on the specific work being done. In this factory, we might find precision molds to shape lenses, UV machines to harden them, X-ray scanners to catch imperfections, and conveyor belts to move finished packs to shipping. Increasingly, so-called smart industrial machines come with built-in computers, sensors, and software, cutting out the need for human operators. The next job is controlling the work, aka controlling the machines. This is done by automation and controls equipment. At the core of this group are small, dedicated industrial computers, found on the factory floor or in a control room. They receive signals from the machines and sensors, say a signal that the box is full, and send back commands, say stop boxing, start the conveyor. These devices are called programmable logic controllers, or PLCs. Automation and controls equipment, like PLCs, connect to so-called supervisory computer systems that monitor and control the whole production process. Those systems, in turn, connect to a factory's other IT systems, like the software that schedules machine maintenance or calculates production needs based on sales forecasts. The details of the supervisory and other IT systems are beyond the focus of this primer. Increasingly, modern industrial machines and sensors can connect directly to these higher-level systems, reducing the need for separate control hardware. Elsewhere in the factory, there are more jobs to do, and more types of equipment to do them. For one, powering the work. You can't just plug industrial machines into a standard wall socket. They often need a stable, uninterrupted supply of power to function safely and effectively. This is the job of electrical equipment, the E in I&E. This equipment includes transformers, which change voltage levels up and down, circuit breakers, which protect machines from power spikes, and backup generators that kick in if the main supply fails. All this equipment is categorized in a different way, by the voltage of the electricity in question: low, medium, and high voltage equipment. In simple terms, low voltage equipment will be used to move low voltage electricity within the factory, high voltage equipment will be used on the power grid, and medium voltage equipment will connect the two. The next job is to manage the work environment, making sure conditions are optimal for production. This is done by the final segment, the building services equipment. This includes more basic systems like AC units and water systems, but it's not just that. Sometimes these are highly specialized mission-critical systems, like sophisticated safety systems to counter chemical leaks. In our contact lens facility, preventing dust would be critical, so high-grade ventilation and filtering might be necessary.